I think so, yeah. Okay. Hi, everyone. So I'm going to do my best to cover everything I can in 15 minutes. So let's get started. Kolams, Code, and Culture towards a universal pattern language. So when I get to the point of a universal pattern language, I'm going to talk to you a little bit about patterns, columns, what they mean to us. So when we look closely at the patterns around us, we begin to see how they've shifted in form, in meaning, as they've traveled across different regions, different cultures. So what if we studied these patterns not as static artifacts of the past, but as living systems of knowledge still unfolding today? You all might be familiar with this, the inlay work, the symmetry of the Taj Mahal. When we encounter it, we admire its artistry, perhaps the geometry that we see, the work of craftsmanship, the mathematics behind it, but we still frame it as an artifact, like something frozen in time. Fewer of us might be familiar with these. Fewer of us might recognize it, but these are columns. They're drawn daily in front of South Indian homes with rice flour. They're ephemeral, they're drawn, they're walked over, and they're remade the next day. In that way, they're not preserved, but they're practiced. Not static, but living. It's similar to one of those, those daily challenges like 36 Days of Type or Inktober that we see on social media, but this is eternal. It's been practiced for several years. So let's understand what a pulley column is. They're a type of column pattern drawn on a grid of dots. Now each dot, or pulley means dot, must be encircled exactly once using continuous looping lines. Some columns are made with a single unbroken path, while others use multiple interwoven loops. These patterns often follow symmetrical rules, radial, parallel, twofold, or more. So their elegance and precision have sparked significant mathematical interest. There's a lot of research papers about columns revealing the logic embedded in this traditional art form. Now, if you've been following the Algorithmic Pattern Salon, you might recognize this work by Anuradha Reddy and Alex's exploration of sashiko embroidery and columns. So in this exploration, column takes another form in thread supported by sashiko embroidery patterns. So the pulleys that guide the continuous line drawing of the column with its evenly spaced grid, this sashiko stitch acts as a guide for thread to loop around the meeting points of these circles. And this helps the loops find their path in thread around these sashiko stitching patterns. So if we look at patterns from around the world, we might recognize several similarities, like interlacing, grid structures, continuous lines, various kinds of symmetry. In Chinese knots, Rishnik patterns, Celtic knot, interlaced Celtic knot stone carvings, and the details inside the Alhambra. So these conceptual similarities exist by design. So what if these patterns that have structural similarities shared their knowledge and created together? So let's begin by understanding what makes a pattern, right? So if we look at these patterns, rice flour becomes columns. These threads turn into kente weaving patterns with the help of looms, and these rocks and marble turn into Islamic interlace patterns. So to make any of these forms, we need materials. These materials undergo processes, and then we have our resulting forms. So this is the algorithmic pattern salon after all. So what makes these patterns algorithmic? So a pattern is formed by regularly repeated arrangements. The algorithm dictates the processes and instruction and rules that the way these elements repeat. And what stood out to me here is, especially if given to a computer. So I guess the process has to take place here inside the computer. And now our inputs now become the characteristic elements that we can distinctly visualize, like shapes, lines, or colors. They undergo a set of operations, functions, logical rules that will be processed by the computer because it's an algorithmic pattern. And the output is a visual expression of this pattern, often built through repeatable logic, generative design. So our pattern system, like our algorithmic pattern system, looks something like this. We have an input process output model with what we just talked about. So we'll understand how pattern systems can collaborate when we break it down into a structure similar to this. So let's start by understanding what columns would look like in a pattern system. So it all begins with the grid, right? The set of dots placed in a specific configuration, the number and arrangement of these dots depending on the size of the column you want to create or the type of the column. And once the grid is set, the column takes shape through a few core visual elements. So the first is the straight line. It's a diagonal stroke drawn at a 45-degree angle. And this line allows you to traverse the grid and connect the curved arcs. Second, the curved arcs. These arcs are used to encircle or flow around the pulleys. They're not random. They're derived from, rounding a square's edges, a square that's rotated at 45 degrees, as you can see here, and are selectively curved, like the different permutations of selective curving of these edges. And these elements, the line and the curved arcs, form the visual vocabulary of columns. And it's shaped entirely by how we choose to configure the grid. So when we want to understand the processes, you can see that these arcs come together to form a continuous closed loop around the pulleys. You don't just travel along the grid using these arc combinations, you also loop back. You go back to where you started because it's a continuous line drawing and it's a closed loop within the same system. So you draw around the dotted grid so you can see how these archetypes combine with one another. And to guide the path, each one working in relation to the other. And one important thing to note is that archetype 3 is unique. It forms a closed loop. So we use it intentionally as the endpoint of a column. So this closed arc, path type 3, signals that the column has to start looping back. So this brings the entire pattern into a single continuous flow. So you can move through a single row, and now to cover a grid, you need to move through the rows and the columns. So to shift to the next row, we use the straight line, that is path type 0, and that way we can move through the rows and columns of the dot to ensure that they're all encircled. So now we know how to move around the grid. So for a column to be fully formed, for it to be complete, every pulley must be encircled completely, and the line must return to its starting point, forming a continuous closed loop, right? So each path type has a specific way it needs to close in order to complete the loop. So when we've moved forward with path type 1, the arc, it's closed by another path type 1. And when we move with path type 2, it's closed by a straight line, and when we have a straight line, it's closed by path type 2. So it looks something like this. So this repeats 3 more times in each quadrant and comes together as the algorithm to generate columns, the output. So it's also important to note that we can have different types of columns. In this exploration, we're focusing on columns that are drawn with just one single continuous line, and it follows a fourfold radial symmetrical structure. So as a pattern system, it comes together with something like this. So in code, we translate these visual elements to numerical values. So the path types are literally numerical values. And you can code this using a recursive function to loop the entered arrays to generate a pattern. So I could run this logic using Python turtle graphics. So it kind of looks something like this. So you can see that the numerical outputs correspond to the path types that we just talked about. And after defining the order and entering the path types that I'm doing here, path type 3 is added to the array at the endpoint of the column, and this sequence is repeated 3 more times. Now this is a beautiful column, but it's not quite as beautiful as this. It's not quite beautiful as the actual column. That brings us to something important that we need to consider when we translate the patterns we see every day into what we deem as algorithmic patterns. We're not just coding a pattern from scratch here. We're uncovering the logic that columns already hold. We're discovering the code that's always been there, that's always been embedded in tradition. We just have a new language now. And beyond logic and structure, why do these patterns matter at all, right? The columns drawn each morning, the tapestry of kente weaving patterns, the precision of orgy tiles, hand-knotted rugs, interlaced arcs, Kanchipuram silk sites. Why do we keep returning to them? And because they're beautiful, and we love beauty, and that's simple and that's powerful. So we have to ask ourselves, when we create today, are we honoring beauty or are we just building? Well, we're more advanced than we've ever been. We've automated design, we've streamlined production, we've optimized for scale. Shouldn't that mean we finally have time to focus on beauty? But here's the thing, beauty takes time, and speed and optimization does not wait. So we have a program now that can generate columns in seconds, geometry at scale, help us render and observe several variations because we're not running out of rice flour. So the real question is, okay, 2 minutes, we got this. So the real question is, how do we honor beauty while we systemize process? Can a pattern still hold meaning when it's mass-produced? How can this knowledge be shared to create something beautiful? We've already seen an example of 2 beautiful pattern systems sharing their knowledge and creating together, the column in embroidery form with a thread acting as a continuous loop facilitated by another pattern system, Sashiko embroidery. And we looked at patterns that shared similarities with columns from other parts of the world. So I came to look at this other knowledge system. Like columns, Islamic interlaced patterns follow rules, symmetries, and transformations. And when we place these patterns alongside columns, clear resonances start to emerge. Both of these have elements of radial symmetry, interlacing forms, continuous line work. They're built from arcs and lines. And more importantly, they both follow a logic of flow, repetition, and transformation. So what happens when we take the visual inputs from one knowledge system, like the arcs and lines of Islamic interlaced patterns, and process them to another logic, like the logic of Kolams? So we're not just borrowing style here, we're allowing two systems of meaning to collaborate through code. So can new beauty emerge when knowledge systems share rules, constraints, and creative intent? So when I look closely at the vocabulary of Islamic patterns, they employ similar formal elements, like curves, interlacing, repetition, a structured rule-based grid system. And what we see here are the fundamental visual elements that make up this interlaced pattern, arcs, lines, and these would be our path types. But these simple forms, turning these simple forms into the intricate language of Islamic interlace, it spans vast, and it's a pattern system that can be studied in its own right. So we're trying to see how we can share this knowledge, right? So what happens when we run the inputs of Islamic interlaced patterns to the process of Kolam? So a shared pattern system would look something like this. We have our input path types that correspond to, the visual elements of Islamic interlaced geometry. And they would follow a similar set of transformations and processes of a column to generate a pattern more similar to interlaced patterns, but a whole new variety of expression. So let's see this in action. So earlier we looked at the same program that generated a column, but this time I changed the inputs to use path types inspired by interlaced patterns. And with a few more adjustments, the results start to look something like this. And these are some more unique forms generated by combining our two systems. So you notice how the aesthetic leans more towards Islamic interlaced patterns while retaining something distinctly new. So this is a demonstration of how Kolams' underlying knowledge can inform and enrich the creation of forms that carry the characteristics of another culture. So this is what we see when we study patterns. This mirrors how beauty has always traveled across cultures, right? Like when we started off. If you move through regions, you can see how architecture reflects different style influences through time, culture, religion, shaping identity. These visual forms don't just decorate the space, they shape identity. They tell stories of exchange, adaptation, and belonging. And when we recognize that, we begin to treat patterns not as fixed artifacts, but as living systems of knowledge, shared, shaped, and still evolving today. And thank you. Oh, we have time.
Thank you. That was wonderful. If you haven't looked at the conference proceedings, I recommend reading Lavanya's paper because you can try out those simulations for yourself. Because we started a bit late, we might just do one question. So any burning questions from the crowd? Okay, could you give me
Hiya, thank you. That's really nice. I love Kolams. I think they're wonderful. Just one thing that occurred to me when you were talking about translating the Islamic things into those. I mean, the Islamic art, if I remember correctly, and some of these other things like Celtic knots and things, they have a notion of overlap between connections, whereas if I remember correctly, Kolams don't really have that. So have you experimented with any notation for which line overlaps and the kind of depth? Because this is what I've struggled with when I've tried to implement pattern drawing things. If it's flat, it's easy, but then when you want to start representing this notion of one thing crossing another, it suddenly gets a lot more complex.
Are you talking about like when we talk, so there's interlacing, and when you say overlap, like it matters which is in front and which is, I've thought about this as well. I've actually studied columns, like, as another pattern system as well. This is not the only pattern system that can illustrate columns. But I would say that column as a system does not have overlap that where the order of it matters. So it might be worthwhile to study the pattern system where this matters, right? Like Celtic. Some of them, yeah, they do, even in some of the examples I've showed you. Yeah, the order is like something I feel like I would need to study deeper, because like you said, it is difficult. It is something I've tried to look into before. But yeah, future explorations.
Cool. Also in the chat, not a question, but Anu was actually watching and says no burning questions. Just want to say this is wonderful and thank you.
Oh my God.
So can we have another round of applause, please?
Thanks, everyone.